You wake up this morning, and time feels like a river carrying you forward. Yesterday is gone, a collection of memories growing fainter. Today is real, vivid, immediate. Tomorrow waits in darkness, uncertain and mysterious. This is how we experience time every single day. It flows like water through our fingers, always moving in one direction, never backward, never stopping. Your alarm clock ticks forward, second by second. The calendar shows days crossed out behind you and blank spaces ahead. Your body ages, your hair grows, memories accumulate. Everything screams that time is moving, progressing from past to present to future like a cosmic conveyor belt. This feeling is so fundamental that we barely question it. We build civilization around temporal flow. We schedule meetings for tomorrow because tomorrow will come. We remember yesterday because yesterday happened. Our languages have past tense, present tense, future tense. We say time flies, time heals wounds, time waits for no one. But what if this basic experience is completely wrong? What if time does not flow at all? What if past, present, and future exist simultaneously in a vast, unchanging structure physicists call the block universe? What if your birth, first kiss, last breath, and every moment between already exist, frozen in four-dimensional space-time, waiting to be experienced, but never moving or changing? This possibility shatters our fundamental assumptions. When you feel time flowing, you might be experiencing an illusion as profound as thinking Earth stands still while the sun moves overhead. The flowing river of time might be a trick of consciousness, a byproduct of how brains process information in a static, unchanging universe. Consider how strange our temporal experience really is. You exist in the present moment, but what exactly is this present? A second long? A millisecond? Try to pin down the present and it shrinks to nothing. The moment you identify as now immediately becomes then. The present appears to be an infinitely thin slice between past and future, a moving boundary carrying consciousness forward through time. Yet this boundary cannot be measured with instruments. You cannot detect temporal flow with scientific devices. Clocks measure intervals between events, but not flow itself. They tick at regular intervals, but ticking is just a sequence of events, not evidence of movement. A movie projector shows 24 frames per second, creating motion illusion, but each frame exists simultaneously on film. Could time be similar, with all moments existing while consciousness creates flow illusion by experiencing them sequentially? Memory and anticipation deepen the puzzle. The past feels fixed, determined, real in ways the future is not. You remember your 10th birthday vividly, cake taste, laughter sounds, present unwrapping feelings, but you cannot remember next Tuesday the same way. You imagine it, plan for it, worry about it, but cannot remember it because it has not happened yet. This asymmetry seems to confirm temporal flow, that real difference exists between what happened and what will happen. But is this fundamental to time itself, or simply how conscious beings process information? Perhaps the universe contains all moments equally, and consciousness accesses some past information while remaining blind to future information. Different cultures conceived time differently throughout history. Ancient Greeks had chronos and kairos. Chronos was quantitative time, clocks and calendars, mechanical and measurable. Kairos was qualitative time, the right moment, meaningful time, experienced rather than measured. Some cultures think of time as circular, history repeating endlessly. Others see spirals, returning to themes at higher levels. These conceptions suggest temporal flow experience might not be universal or fundamental. It might be a particular way of organizing experience that emerged in human consciousness, shaped by evolution, culture, and specific brain information processing. If time does not flow, then these different approaches are attempts to understand something mismatched with direct experience. The implications stagger. If time does not flow, then change is illusion. Nothing actually becomes different because all moments exist equally. Your younger self is not gone. It exists at different space-time locations, as real as your current self. Your older self is not approaching. It already exists, waiting at different coordinates. Every joy and sorrow, triumph and tragedy, birth and death, exists forever in eternal block universe structure. This challenges everything we think we know. It suggests becoming is illusion. Only being is real. The universe is not process, but thing. Not movie, but sculpture. Not river, but landscape. Time does not pass. Rather, we pass through time, experiencing different slices of unchanging eternal reality. Yet flowing time experience is immediate, compelling, seemingly impossible to doubt. When your heart beats, when the sun sets, when children grow up, you witness change happening in real time. The present feels uniquely real and vivid compared to past memories and future anticipations. How could something so fundamental to consciousness be completely illusory? Perhaps illusions can be real experiences of unreal things. Magic tricks create real experiences of impossible events, even though impossible things are not happening. Rainbows create real experiences of colored sky bands, even though rainbows are not physical objects, but optical effects created by your position relative to sunlight and water droplets. The experience is real, the interpretation is mistaken. Could temporal flow be similar? Could we experience passage while living in static, unchanging block universe? Could consciousness create vivid flow experience through eternal, unchanging space-time landscape? Answering these questions requires diving into modern physics, where common sense fails and reality becomes stranger than anything evolutionary ancestors could imagine. Consider this. Every clock glance shows current configuration of gears, springs, electronic circuits. You interpret changing configuration as time passage, but clocks simply change internal structure in regular ways. Clocks do not measure flowing time. They participate in coordinated universal dance of physical systems. All systems change together in patterns we interpret as temporal flow, but perhaps they are arranged in patterns across time dimension, like beads on strings or movie frames. This means physics might hold keys to understanding time completely differently. Instead of assuming time flows and understanding how physics works within that flow, perhaps we should let physics tell us what time really is. When physics speaks, it tells stories few people are prepared to hear. It tells us time is not what it seems, that flowing temporal experience might be the greatest illusion ever discovered. Ancient philosophers debated time's nature. Heraclitus said you cannot step into the same river twice, emphasizing constant change. Parmenides argued that change is illusion, that reality is eternal and unchanging. These debates echo today in physics laboratories, where scientists probe time's deepest secrets with particle accelerators and gravitational wave detectors. Modern experiments reveal time's strange properties. GPS satellites must account for time dilation effects, or navigation systems would fail within hours. Atomic clocks run differently at various altitudes due to gravitational time effects. Particle accelerators show that fast-moving particles experience time differently than stationary ones. These are not theoretical curiosities, but practical realities that technology must accommodate. The journey into understanding time's true nature begins with revolutionary insights that changed everything we thought we knew about space, time, and reality itself. These insights come from unlikely source. A young patent clerk in Switzerland who looked at the universe with fresh eyes and saw something no one had seen before. His name was Albert Einstein, and his discoveries about space and time would shake the foundations of human understanding and point toward a radically different picture of temporal reality. Albert Einstein was 26 years old in 1905, working 6 days a week at the Swiss Patent Office in Bern, evaluating inventions for electromagnetic devices and mechanical clocks. By day, he analyzed other people's ideas. By night, he revolutionized our understanding of the universe. That year, he published 4 papers that would forever change physics. The most radical dealt with something so fundamental that no one had questioned it for centuries: the nature of time itself. For over 200 years, scientists had accepted Isaac Newton's vision of absolute time. Newton imagined time as flowing uniformly throughout the universe, like a cosmic metronome keeping perfect rhythm. Somewhere in the heavens, Newton believed, there ticked a master clock that defined simultaneity for all observers. If something happened on Earth at precisely noon, then noon existed simultaneously everywhere in the universe, from the nearest star to the most distant galaxy. This seemed obviously true. When you and a friend synchronize your watches, you both experience the same present moment. When astronomers observe a supernova explosion, they calculate exactly when it occurred by accounting for light travel time. The idea that events could happen at different times for different observers seemed absurd, a violation of common sense so basic that questioning it bordered on madness. Einstein questioned it anyway. He started with a simple observation. Light travels at a finite speed of approximately 300,000 kilometers per second in vacuum. This speed appears constant regardless of how fast the light source moves. Whether light comes from a stationary bulb or a speeding train, it always travels at the same velocity relative to any observer. This constancy creates a puzzle. Imagine you and your friend are separated by vast distance in space. You flash a light signal to coordinate your clocks. From your perspective, the light travels at 300,000 kilometers per second toward your friend. But what if your friend is moving toward you at high speed? Common sense suggests the light should reach them faster, like a baseball thrown from a moving car hits the windshield of an oncoming vehicle harder than one thrown from a stationary position. But light does not behave like baseballs. No matter how fast your friend approaches, the light signal still travels at exactly 300,000 kilometers per second relative to them. This means that time itself must adjust to keep light speed constant. If your friend is moving rapidly toward the light source, their clocks must run slower to compensate. Time itself stretches and compresses to preserve the cosmic speed limit. Einstein realized this destroys the idea of universal simultaneity. Events that appear simultaneous to you occur at different times for observers moving at different velocities. There is no master clock ticking in the heavens, no universal now that defines the same present moment throughout the cosmos. Instead, each observer carries their own time, their own definition of simultaneity, their own slice through the fabric of space-time. Consider 2 lightning bolts striking opposite ends of a moving train. A passenger at the train's center sees both flashes simultaneously because light from each bolt travels the same distance to reach them. But an observer standing on the platform sees the flashes at different times. As the train moves forward, it carries the passenger toward the light from the front bolt and away from the light from the rear bolt. From the platform observer's perspective, the front flash occurs first. Which observer is correct? Einstein's revolutionary answer: both. There is no absolute truth about when events occur. Simultaneity depends on motion. The universe has no universal present moment, no cosmic now that everyone shares. Instead, reality consists of individual world lines threading through 4-dimensional space-time. each carrying its own time, each defining its own sequence of events. This insight led Einstein to general relativity 10 years later. He realized that gravity is not a force pulling objects together, but the curvature of space-time itself. Massive objects like stars and planets warp the fabric of space and time around them. What we experience as gravitational attraction is actually objects following the straightest possible paths through curved space-time. Near massive objects, time runs slower. Clocks at the bottom of gravitational wells tick more slowly than clocks at higher altitudes. This is not mechanical effect, but fundamental property of time itself. GPS satellites orbiting Earth experience weaker gravity than ground-based receivers, so their clocks run faster by about 38 microseconds per day. Without correcting for this effect, GPS navigation would accumulate errors of several kilometers daily. Einstein's equations describe spacetime as unified four-dimensional structure. Just as you cannot separate length from width from height in describing three-dimensional space, you cannot separate space from time in describing four-dimensional space-time. Time becomes the fourth dimension, woven inextricably with the three spatial dimensions into single geometric entity. Hermann Minkowski, Einstein's former mathematics professor, developed this geometric interpretation further. In 1908, Minkowski declared that space and time as separate entities were doomed to fade into shadows, and only their union would preserve independent reality. He visualized space-time as four-dimensional block where all events, past, present, and future, exist as geometric points located by four coordinates, 3 for space, 1 for time. In Minkowski space-time, your entire life forms a world line, a four-dimensional curve threading through the block from birth to death. Every moment you have ever experienced or will experience exists as a point along this curve. Your first day of school, your graduation, your wedding, your retirement, all exist simultaneously as different locations in space-time, like different cities along a highway. This block universe picture eliminates the flow of time entirely. Nothing moves through time because time is just another dimension like space. You do not travel from past to future any more than New York travels from east to west. Events simply exist at their space-time coordinates, arranged in four-dimensional patterns that we interpret as temporal sequence. The implications are profound. If past, present, and future all exist equally in the block universe, then the distinction between them is psychological rather than physical. Your memories of childhood correspond to real events at specific space-time locations, no less real than your current experiences. Your future death exists at some other space-time coordinate, as definite and unchangeable as your past birth. Einstein himself embraced this view. When his lifelong friend Michel Besso died, Einstein wrote to Besso's family that for believers in physics, the distinction between past, present, and future is only stubbornly persistent illusion. Death cannot truly separate friends because they exist eternally at their respective space-time locations, frozen forever in four-dimensional amber. Yet this picture seems to contradict everything we experience about temporal flow. If all moments exist equally, why do we remember the past but not the future? Why does cause precede effect? Why do we age in one direction through time, rather than randomly experiencing different life stages? Einstein's relativity does not answer these questions directly. It tells us that space-time is a unified block where all events coexist, but it does not explain why consciousness experiences this block sequentially, rather than all at once. The flowing river of subjective time remains mysterious even in the static landscape of objective space-time. Some physicists argue that relativity demands the block universe interpretation. If simultaneity is relative, then there cannot be objective distinction between past, present, and future. Events that are in your future might be in the past for observers moving at high speeds relative to you. This means your future already exists in some absolute sense, even though you have not experienced it yet. Other scientists remain skeptical. They argue that relativity describes the structure of space-time, but not necessarily the nature of existence itself. Perhaps the block universe is mathematical convenience rather than literal description of reality. Perhaps time really does flow, but in ways that relativity cannot capture. The debate continues in physics journals and conference halls around the world. But Einstein's insights have fundamentally changed how we think about time. Whether or not time actually flows, it certainly does not flow the way Newton imagined. There is no universal clock, no cosmic metronome, no absolute simultaneity that defines the same present moment throughout the universe. Instead, we live in a relativistic universe where time bends and stretches, where simultaneity depends on motion, where past and future lose their absolute meanings. This is the universe revealed by careful observation and mathematical analysis, not the universe of common sense and everyday experience. Modern experiments continue to confirm Einstein's predictions. Atomic clocks flown on airplanes return, having measured different elapsed times than identical clocks left on the ground. Particle accelerators routinely observe time dilation effects, as fast-moving particles live longer than their stationary counterparts. Gravitational wave detectors must account for relativistic time effects to achieve the precision needed to detect ripples in space-time itself. The block universe remains one of the most startling implications of modern physics. It suggests that reality is far stranger than our ancestors imagined, that time is not the flowing river of human experience, but the static dimension of mathematical space-time. Whether this mathematical description corresponds to literal truth about the nature of existence remains one of the deepest questions in physics and philosophy. Picture reality as a vast sculpture carved from four-dimensional stone. Every event that has ever occurred or will ever occur exists as a permanent feature in this cosmic artwork. Your birth is there, chiseled into the space-time at coordinates corresponding to the year you were born, the hospital where you entered the world, the precise moment when you took your first breath. Your death is there too, carved with equal permanence at different coordinates, waiting in the future section of the sculpture like a distant mountain peak. This is the block universe, and it represents one of the most radical departures from common sense ever proposed by science. In this view, the past has not disappeared, and the future has not yet come into being. Instead, all moments exist simultaneously, spread out across the time dimension like houses spread out across a city. Just as Paris and London exist at the same time, despite being separated by space, your childhood and your old age exist at the same time, despite being separated by temporal distance. The block universe eliminates becoming entirely. Nothing ever comes into existence or passes out of existence. Things simply exist at their designated space-time locations. A flower does not bloom and then wither. Rather, different stages of the flower exist at different temporal coordinates. The seed exists at one time coordinate, the sprout at another, the full bloom at a third, and the withered remains at a fourth. All these stages are equally real, equally present in the four-dimensional landscape of space-time. Consider what this means for your own existence. Right now, you experience yourself as a particular age with particular memories and particular concerns about the future. But in the block universe, every version of yourself exists simultaneously. Your 5-year-old self is playing with toys at one set of space-time coordinates. Your 20-year-old self is falling in love at different coordinates. Your 80-year-old self is reflecting on a life well lived at yet another location in the temporal dimension. These different versions of yourself are not memories or possibilities. They are equally real aspects of your four-dimensional existence. Your current experience represents just one slice through your world line, one cross-section of your extended temporal being. You are not a three-dimensional object moving through time. You are a four-dimensional object existing across time, with different temporal parts at different temporal locations. This perspective transforms how we understand identity and persistence. What makes you the same person from childhood to old age? In the block universe, you are literally the same four-dimensional object, extending from birth to death through the time dimension. Your identity consists not in some unchanging essence that persists through time, but in the pattern of connections linking different temporal stages of your world line. Death loses much of its sting in this view. When someone dies, they do not cease to exist. They simply reach the end of their world line. But all the earlier parts of their world line remain eternally present in the block universe. Their childhood, their youth, their prime of life, all exist forever at their respective space-time coordinates. In a very real sense, no one ever truly dies in the block universe. They are simply located elsewhere in time. Yet this raises disturbing questions about change and growth. If all moments exist equally, then improvement seems impossible. How can you become a better person if your current self and your future better self both exist simultaneously? How can you learn from mistakes if those mistakes are eternally present in the block universe? How can anything meaningful happen if everything that will happen already exists? The block universe seems to reduce life to a static sculpture where nothing really changes. Your struggles and efforts appear pointless if your future is already carved in stone at definite space-time coordinates. Your choices seem illusory if the outcomes already exist alongside the decisions themselves. This is the frozen universe, a cosmos where becoming is replaced by mere being, where the dynamic dance of existence gives way to eternal stillness. But perhaps this view misunderstands what change means in a block universe. Consider a river flowing through a landscape. From the river's perspective, it is constantly moving, flowing from its source toward the sea. But from the perspective of someone viewing the entire landscape from above, the river simply exists as a blue line connecting 2 points. The river's flow is real from one perspective and static from another. Similarly, your life might be genuinely dynamic from your temporal perspective, while being static from the atemporal perspective of the block universe. As your consciousness moves along your world line, experiencing different temporal slices in sequence, you encounter real change, real growth, real development. The fact that all these changes exist simultaneously in four-dimensional space-time does not make them less real or less meaningful. Think of reading a book. The entire story exists simultaneously on the printed pages, with beginning, middle, and end all equally present. Yet as you read, you experience genuine narrative development, character growth, plot twists, and emotional satisfaction. The story's simultaneous existence does not diminish your experience of its unfolding. Perhaps life in a block universe is similar, with consciousness reading the story of existence one moment at a time. This analogy suggests that the block universe might preserve meaning while eliminating temporal flow. Your efforts to improve yourself are real and effective. They shape the trajectory of your world line through space-time. Your choices matter because they determine which path your world line follows among the many possible paths. Your relationships have meaning because they create connections between different world lines threading through the cosmic sculpture. Love takes on new dimensions in this picture. When you love someone, you love their entire four-dimensional existence, not just their current temporal slice. Your beloved exists across time, with their childhood innocence, their youthful passion, their mature wisdom, and their eventual aging all equally real and equally lovable. Death cannot separate you because they exist eternally in the block universe, accessible through memory and forever present at their space-time coordinates. Grief becomes more complex in this view. You mourn not the annihilation of your loved one, but your inability to share new experiences with them. They exist as fully as ever in the past sections of the block universe. But you cannot join them there because your world line moves forward through time. They are not gone, they are elsewhere, located at temporal coordinates you cannot revisit. The block universe also transforms how we think about the present moment. In normal experience, now seems special, privileged, more real than past or future. But in the block universe, now is just your current location in time. No more special than here is your current location in space. Just as here has no objective significance beyond your personal reference point, now has no objective significance beyond your temporal reference point. This elimination of the special present might seem to rob life of immediacy and urgency. If future moments exist as fully as present moments, why worry about preparing for them? If past moments exist as fully as present moments, why not dwell in nostalgia rather than engaging with current challenges? The block universe seems to discourage engagement with temporal flow by revealing it as illusion. But perhaps urgency and immediacy remain meaningful from your perspective within the block. Even if your future self already exists at other temporal coordinates, you cannot access that existence directly. You can only experience your current temporal location with its particular knowledge, capabilities, and circumstances. Your future self might have solved problems that currently perplex you, but that solution exists at temporal coordinates you have not yet reached. This creates a kind of indexical meaning that survives the block universe. What matters is not whether events are objectively present or future, but whether they are present or future relative to your current temporal location. From your perspective, embedded within the block and experiencing it sequentially, the future remains unknown and the past remains fixed, even if both exist simultaneously in the larger space-time structure. The block universe forces us to distinguish between two kinds of time: coordinate time and experience time. Coordinate time is the time of physics, the fourth dimension of space-time, the temporal coordinate that labels when events occur. Experience time is the time of consciousness, the flowing now that carries your awareness from moment to moment through your world line. These might be completely different phenomena, related the way a map is related to a territory. This distinction offers hope for reconciling the static block universe with dynamic human experience. The block universe might describe the objective structure of space-time without describing the nature of consciousness within that structure. Perhaps consciousness creates its own temporal flow by reading through the static moments of the block, generating the experience of passage without requiring actual passage. Yet questions remain about how consciousness could create such convincing illusions of temporal flow. Why does consciousness experience moments sequentially rather than all at once? What mechanism forces awareness to move along world lines rather than jumping randomly through the block? Why do we remember the past but not the future if both exist equally? These questions point toward deeper mysteries about the relationship between mind and time. In the block universe, consciousness becomes a spotlight, illuminating different sections of your world line in sequence. But what powers this spotlight? What determines its direction and speed? Why does it seem to move smoothly rather than flickering randomly between distant temporal locations? Some philosophers suggest that the answer lies in the structure of memory and anticipation. Memory creates connections between your current temporal location and earlier locations along your world line. These connections give you access to information about past events, creating the impression that those events happened before your current experience. But memory works in only one temporal direction because of deeper physical principles that we will explore in later chapters. Anticipation works differently than memory. Instead of connecting you to actual future events, anticipation generates predictions based on current information and past patterns. These predictions might be accurate or inaccurate, but they are fundamentally different from memories, which connect directly to events that actually occurred at other temporal coordinates. This asymmetry between memory and anticipation creates the psychological arrow of time, the sense that past and future are fundamentally different, even if they exist equally in the block universe. Consider how this affects planning and decision-making. When you plan for the future, you are not accessing information about events that already exist at future temporal coordinates. Instead, you are using current information to generate predictions about what those future events might be like. Your planning efforts can influence which future actually occurs by shaping the trajectory of your world line through space-time. This preserves genuine agency even in a block universe. Your decisions matter because they participate in determining the shape of your world line. The future exists, but it exists partially because of choices you make in the present. Your current decisions are among the factors that make the future what it is, written into the eternal structure of space-time. But this raises puzzling questions about causation and determination. If your future self already exists in the block universe, then your current decisions seem to be determined by that future existence. Yet your future existence seems to depend on your current decisions. This creates a kind of temporal loop, where past and future mutually determine each other, rather than past determining future in simple linear sequence. Perhaps causation in the block universe works more like architectural support than temporal pushing. In a building, the foundation supports the upper floors, but the upper floors also help hold the structure together through complex engineering relationships. Similarly, earlier events might support later events, while later events help determine the overall pattern that makes earlier events possible. This holistic view of causation fits naturally with the block universe picture. Instead of events pushing other events forward through time like dominoes falling in sequence, all events exist together in a self-consistent pattern that makes the entire structure possible. Causation becomes relationship rather than process, pattern rather than pushing, geometry rather than dynamics. The block universe also transforms our understanding of possibility and necessity. In normal thinking, the past is fixed and necessary, while the future is open and possible. What happened had to happen because it did happen, but what will happen might happen differently because it has not happened yet. The block universe eliminates this distinction by making all events equally fixed and equally necessary. This means that your future is as determined as your past, but not in the sense that some external force compels it to unfold in a particular way. Rather, your future is determined in the same way that your past is determined. It is what it is, because that is how the universe is structured. Your future self exists at specific space-time coordinates, not because something forced them there, but because that is where they are located in the four-dimensional architecture of reality. This view might seem to eliminate genuine possibility, but perhaps it simply relocates possibility from temporal to logical space. Instead of asking what will happen next, we might ask what could be happening at different space-time coordinates. Instead of wondering whether alternative futures are possible, we might wonder whether alternative block universes are possible. Possibility becomes a question about the space of conceivable space-time geometries, rather than the space of potential temporal developments. Free will becomes particularly puzzling in this context. If your future actions already exist in the block universe, then it seems you cannot do otherwise than what you actually do. Your sense of choosing between alternatives appears illusory because your actual choice is already carved into the space-time structure. The alternative actions you consider but do not take seem to have no reality beyond your imagination. Yet the block universe might preserve a different kind of freedom. Perhaps free will consists not in the ability to do otherwise, but in the ability to be the author of your own actions. Your future self exists because you choose to bring that self into being through your current decisions. The fact that your choice already exists in the block universe does not make it less your choice or less free. This conception of freedom emphasizes ownership rather than alternatives. You are free when your actions flow from your own values, desires, and reasoning processes, regardless of whether you could have acted differently. Your future self belongs to you because it results from your own decision-making processes, even if that future self already exists at definite space-time coordinates. The block universe also affects how we think about moral responsibility. If someone commits a crime, are they responsible for an action that already existed in the space-time structure? If someone performs a heroic deed, do they deserve praise for actualizing something that was always present in the block universe? Perhaps moral responsibility survives in modified form. People remain responsible for their actions because those actions express their character, values, and choices, regardless of the temporal structure in which those expressions exist. A cruel action reveals cruelty. A kind action reveals kindness, whether the action exists in flowing time or eternal space-time. The block universe might even enhance certain aspects of moral thinking. If all moments exist equally, then past suffering is not diminished by temporal distance. The pain of historical atrocities remains fully real in the space-time structure, not relegated to non-existent pastness. This might strengthen arguments for historical justice and remembrance. Similarly, if future generations already exist in the block universe, then our obligations to them become as concrete as our obligations to present people. Environmental destruction harms real people who exist at future temporal coordinates, not merely possible people who might come into existence. This could provide stronger motivation for long-term thinking and sustainable practices. Art and beauty take on new meanings in this eternal context. A piece of music does not unfold through time, but exists complete in the block universe, with all its notes simultaneously present at different temporal coordinates. Yet we still experience it sequentially as our consciousness moves through the temporal dimension, encountering each note in turn and appreciating the relationships between them. Perhaps this dual nature of artistic experience, simultaneous in the block but sequential in consciousness, reveals something deep about the relationship between objective reality and subjective experience. The music exists completely in space-time, but it becomes meaningful through conscious experience that unfolds in psychological time. The block universe forces us to reconsider what it means for something to be real. Past events seem less real than present events in ordinary experience, and future events seem even less real or not real at all. But if all temporal locations are equally valid positions in space-time, then all events are equally real regardless of their temporal coordinates. This equal reality of all moments might explain certain puzzling aspects of human experience. Why do childhood memories sometimes feel more vivid and immediate than current experiences? Perhaps because they are equally real in the block universe, equally present in the space-time structure, equally valid locations in the four-dimensional landscape of your existence. The assault on time's flow begins with a simple but devastating observation. There is no universal present moment. This fact, established by Einstein's relativity, strikes at the heart of our temporal intuitions. If time truly flows like a river, then there should be a cosmic now that defines simultaneity throughout the universe. Events should be unambiguously past, present, or future for all observers. But relativity reveals that simultaneity is relative, that your now differs from the now of anyone moving at different velocity. Consider two observers, Alice and Bob, moving past each other at high speed. Alice defines her present moment by all events that are simultaneous with her current experience. Bob, moving rapidly relative to Alice, defines a completely different set of events as simultaneous with his present moment. Events that Alice considers future might be present for Bob. Events that Bob considers past might be present for Alice. There is no objective fact about which events are really happening now because there is no universal now. This relativity of simultaneity demolishes the flowing river metaphor. Rivers have a definite direction of flow, a clear boundary between upstream and downstream, a universal sense in which water moves from source to mouth. But time has no such universal direction. What counts as forward in time depends on your reference frame, your state of motion, your position in gravitational fields. The block universe emerges naturally from this relativity. If there is no universal present, then all moments must exist equally. The distinction between past, present, and future becomes merely perspectival, like the distinction between left and right, or up and down. Your past and future are as real as events in distant galaxies that you consider simultaneous with your present. But perhaps the most powerful argument against temporal flow comes from physics itself. Search through the fundamental equations that govern reality, from quantum mechanics to general relativity to particle physics, and you will find something startling. None of them contain time flowing. The equations describe how things are arranged in space-time, but they do not describe time passing or moving or evolving from one moment to the next. Newton's laws of motion describe how objects move through space in response to forces, but they treat time as a parameter, a coordinate for labeling when things happen. Einstein's field equations describe how matter and energy curve space-time, but they treat time as a dimension, not a flowing medium. The Schrödinger equation describes how quantum systems evolve, but it treats temporal evolution as mathematical relationship between states at different time coordinates. These equations are time-symmetric in a profound sense. Most fundamental physical laws work equally well forward or backward in time. If you filmed a movie of two billiard balls colliding and ran it backward, the reversed motion would still obey the same physical laws. The equations cannot tell you which direction is really forward in time because they do not contain any concept of temporal flow. This suggests that flow is not fundamental to time, but something we add to our interpretation of timeless physical laws. We imagine time flowing because of how consciousness processes information, not because of any feature of space-time itself. The universe might be fundamentally static, with apparent change arising from relationships between events at different temporal coordinates. Think about this carefully. Every measurement you make, every observation you record, every experiment you perform reveals only correlations between events at different space-time locations. You never measure time itself flowing. You measure how clocks change their readings, how particles change their positions, how fields change their configurations. But change is relationship between states at different temporal coordinates, not evidence that time carries things from one coordinate to another. Even the language we use to describe temporal flow reveals its problematic nature. We say time passes at 1 second per second, but this is circular reasoning. The rate of time's passage would have to be measured against some more fundamental temporal standard, leading to infinite regress. We say events move from future to present to past, but move implies change of position over time, which presupposes the very temporal flow we are trying to explain. Consider what it would mean for time to stop flowing. If time stopped, would clocks stop ticking? Would processes stop changing? Would consciousness stop experiencing? But stopping implies temporal change, the change from flowing to not flowing. The very concept of time stopping presupposes time continuing in order to define the transition. This logical puzzle suggests that temporal flow is incoherent as a fundamental concept. The block universe dissolves these puzzles by eliminating flow entirely. In the block universe, nothing moves through time because time is not something to move through. Instead, events simply exist at their designated space-time coordinates. related to other events by geometric relationships in four-dimensional space-time. Change becomes correlation between events at different temporal locations, rather than evolution from one moment to the next. This perspective explains why physics equations are time-symmetric. The equations describe geometric relationships in space-time rather than processes unfolding through time. A collision between two particles is not an event that happens and then is over. It is a feature of space-time geometry, a place where two world lines intersect, as permanent and unchanging as the location where two roads cross. Modern physics provides increasingly strong evidence against temporal flow. Quantum mechanics reveals that the universe at its deepest level consists of probability amplitudes distributed across space-time rather than definite objects evolving through time. These amplitudes exist simultaneously at all space-time coordinates, with no preferred temporal direction or flowing present moment. Particle physics experiments regularly observe time-symmetric phenomena. Certain particle interactions work identically forward or backward in time, confirming that the fundamental laws contain no intrinsic temporal direction. When physicists observe apparent time asymmetries, they trace them to boundary conditions or statistical effects rather than fundamental temporal flow. Cosmology increasingly treats time as emergent property rather than fundamental feature of reality. In quantum gravity theories, time might emerge from more basic, timeless structures, like temperature emerges from molecular motion, or pressure emerges from particle collisions. The universe at its deepest level might be timeless, with temporal flow arising only at macroscopic scales through thermodynamic processes. But the argument against temporal flow goes deeper than physics. It strikes at the logical coherence of flow itself. What could it mean for time to flow? Flow requires motion, but motion requires time. To say time flows is to say time changes position in time, which is either meaningless or requires a second temporal dimension for the first temporal dimension to flow through. Some philosophers propose such higher dimensional time, but this leads to infinite regress. If time flows through supertime, then supertime must flow through super-supertime, and so on forever. The only coherent resolution is to eliminate flow entirely and treat time as static dimension, like space. The argument from physics is reinforced by arguments from consciousness. Our experience of temporal flow might result from how memory works, rather than how time works. Memory creates records of past events, but not future events, generating a symmetry between past and future that we interpret as flow. But this asymmetry reflects the thermodynamic arrow of time rather than fundamental temporal passage. Consider that you never actually experience temporal flow itself, only changes in the contents of your experience. You notice that your thoughts change, your perceptions change, your bodily sensations change. But this change is difference between the contents of experience at different times, not movement of experience through time. The flow you think you perceive might be constructed by consciousness, comparing different temporal stages of your world line. Neuroscience supports this interpretation. Brain imaging reveals that our sense of present moment is constructed from neural activity, spanning several hundred milliseconds. Your experience of now is not instantaneous snapshot, but temporal integration of recent neural events. This suggests that consciousness creates the illusion of flowing present by combining information from slightly different temporal coordinates. The argument against temporal flow gains support from careful analysis of causation. We often think causes push effects forward through time, creating the flow from past to future. But modern physics reveals causation as constraint satisfaction rather than temporal pushing. Events are arranged in space-time patterns that satisfy physical laws, not pushed from earlier to later moments by causal forces. Think of causation like architectural support. In a Gothic cathedral, the flying buttresses support the walls, but the walls also constrain where the buttresses can be placed. The entire structure exists as integrated whole, where each part supports and constrains every other part. Similarly, events in space-time might exist in patterns where earlier events support later events, while later events constrain earlier events. This view eliminates causal flow while preserving causal relationships. Causes and effects are related by geometric patterns in space-time, rather than temporal processes. The relationship between striking a match and the resulting flame is like the relationship between the base and peak of a mountain, geometric rather than dynamic, structural rather than processual. Even our language betrays the incoherence of temporal flow. We speak of time as if it were a substance that could flow, but substances flow through space over time, not through time over time. We metaphorically treat time as a river, but rivers are collections of water molecules moving through space over time. What would be the temporal analogue of water molecules, and through what medium would they flow? These linguistic metaphors reveal that temporal flow is conceptual confusion rather than physical reality. We project spatial metaphors onto time because spatial motion is familiar and temporal flow is mysterious. But the mystery arises because temporal flow is impossible rather than because it is too subtle for ordinary understanding. The block universe resolves the mystery by eliminating it. There is no temporal flow to understand because there is no temporal flow to exist. Time is dimension like space. Events are located in space-time like objects are located in space, and relationships between events are geometric rather than dynamic. The apparent flow of time is artifact of consciousness, not feature of reality. Yet this conclusion seems to contradict our most direct and immediate experience. We feel time flowing with absolute conviction. Every moment of conscious life confirms that time passes, that events move from future through present to past, that now is privileged over then. How can physics and philosophy tell us that our most basic experience is completely illusory? Perhaps the answer lies in understanding that illusions can be both false and inevitable. Even knowing that Earth rotates rather than the sun moving across the sky, you still see the sun rising and setting. Even knowing that rainbows are optical effects rather than physical objects, you still see colored bands in the sky. Perhaps even knowing that time does not flow, you still experience temporal passage, because that is how consciousness interfaces with the static block universe. This suggests that the debate between flowing time and block universe is not simply about which view is correct, but about which level of description is most fundamental. The flowing experience might be real feature of consciousness, while the static block is real feature of space-time. The challenge is understanding how these different levels of description relate to each other. Drop an ice cube into a hot cup of coffee and watch what happens. The ice melts, the coffee cools, and heat spreads evenly throughout the liquid until everything reaches the same lukewarm temperature. You will never see the reverse process. Lukewarm coffee spontaneously separating into hot liquid and solid ice. This irreversible progression from organized energy to disorganized energy reveals the arrow of time, the universal tendency for entropy to increase that gives temporal direction to an otherwise symmetric universe. Entropy is a measure of disorder, of how spread out and mixed up energy becomes in any isolated system. When the ice cube melts, highly organized thermal energy becomes disorganized and distributed. The concentrated cold of the ice and concentrated heat of the coffee become the uniform warmth of the final mixture. This transition from low entropy to high entropy happens spontaneously and irreversibly, defining a clear direction through time. This thermodynamic arrow appears to contradict the block universe picture. If all moments exist equally in static spacetime, why does entropy increase in one temporal direction rather than decreasing or remaining constant? If time does not flow, what forces entropy to climb steadily upward through the temporal dimension? The answer reveals how the block universe can accommodate temporal asymmetry without requiring temporal flow. The key insight comes from understanding that the arrow of time points not forward through time, but upward through entropy space. The universe began in an extraordinarily low entropy state and has been evolving toward higher entropy ever since. This evolution does not require time to flow. It simply means that entropy values are correlated with temporal coordinates throughout the block universe. Imagine the block universe as a vast landscape where altitude represents entropy rather than spatial height. Early cosmic times correspond to low valleys where entropy is minimal. Later cosmic times correspond to high peaks where entropy is maximal. The thermodynamic arrow of time is like the gradient of this landscape, always pointing from low entropy valleys toward high entropy peaks. This entropic landscape exists all at once in the block universe, with no temporal evolution required. Low entropy events exist at certain space-time coordinates. High entropy events exist at other coordinates, and the pattern of increasing entropy emerges from the geometric arrangement of these coordinates. The arrow of time becomes a feature of space-time geography rather than temporal flow. Consider what this means for everyday, irreversible processes. When you break an egg, you transform a low entropy configuration where proteins are neatly organized into a high entropy configuration where they are scrambled and mixed. In the block universe, both configurations exist simultaneously at different temporal coordinates. The broken egg does not evolve from the intact egg. Rather, the intact egg exists at earlier temporal coordinates, and the broken egg exists at later temporal coordinates, with entropy increasing across the spatial separation between these locations. Yet this raises a profound puzzle. Why did the universe begin with such extraordinarily low entropy? The early cosmos was incredibly organized compared to what we observe today. Matter was distributed almost uniformly throughout space, with only tiny fluctuations that would later grow into galaxies and stars. Temperatures were nearly constant everywhere. Energy was concentrated in high-temperature radiation rather than spread thinly across empty space. This initial condition seems highly improbable from a statistical perspective. If you randomly arranged all the matter and energy in the universe, you would almost certainly get a high-entropy configuration rather than the low-entropy state we observe in the cosmic past. The probability of accidentally creating the organized early universe is so small that it defies comprehension, like randomly shuffling a deck of cards and accidentally arranging them in perfect order. Some physicists argue that this improbability is evidence against the block universe interpretation. If all temporal states exist equally, they claim, then low entropy and high entropy configurations should be equally common throughout space-time. The fact that we observe a clear entropic gradient suggests that the universe really does evolve from low entropy to high entropy, requiring genuine temporal flow rather than static geometric arrangement. But this argument misunderstands the relationship between probability and existence in the block universe. The block universe does not require all possible configurations to exist equally. Instead, it describes whatever configuration actually exists, regardless of how probable or improbable that configuration might be from some abstract statistical perspective. Our universe happens to have a low entropy boundary condition at early times, and this boundary condition generates the entropy gradient we observe throughout space-time. Think of it this way. In a randomly generated landscape, most points would be at moderate elevation with occasional peaks and valleys scattered throughout. But actual landscapes are not randomly generated. They result from specific geological processes that create systematic patterns of elevation change. Mountains rise from tectonic forces, rivers carve valleys through erosion, and the resulting topography shows clear directional features rather than random variation. Similarly, our spacetime might not be randomly generated, but might result from specific cosmological processes that create systematic patterns of entropy change. The Big Bang represents a special boundary condition that establishes low entropy at early times, and the subsequent entropy increase represents geometric features of spacetime rather than temporal evolution. This perspective suggests that the arrow of time is fundamental to our universe's structure, but not fundamental to time itself. Time as a dimension is symmetric and reversible, but our particular spacetime happens to contain an entropy gradient that defines a preferred direction. Other possible universes might have different entropy patterns, or no entropy patterns at all, but they would still contain time as a dimension even if they lacked a clear temporal arrow. The cosmic microwave background provides dramatic evidence for this view. This radiation fills the entire universe and represents thermal echoes from the Big Bang, when the cosmos first became transparent to light. The near-perfect uniformity of this radiation across the sky reveals that the early universe was in a remarkably low entropy state, with temperature variations of only 1 part in 100,000. But tiny fluctuations in this cosmic background radiation contain the seeds of all later structure formation. Regions that were slightly denser than average eventually collapsed under gravity to form galaxies, stars, and planets. Regions that were slightly less dense than average became the vast empty spaces between galactic clusters. The entropy increase of cosmic history can be traced back to the amplification of these minute initial fluctuations. In the block universe picture, this entire process exists simultaneously across the time dimension. The smooth early universe exists at early temporal coordinates. The lumpy modern universe exists at later temporal coordinates, and the entropy increase connecting them represents geometric relationships in spacetime rather than temporal evolution. The cosmic microwave background is not an ancient signal that traveled through time to reach us, but a feature of spacetime geometry that connects early and late temporal regions. This view transforms our understanding of cosmic history. The formation of galaxies is not a process that took billions of years to unfold, but a pattern that spans billions of years of temporal coordinate space. Star formation is not stellar evolution through time, but stellar structure across time. The birth and death of stars are not temporal events, but geometric features of spacetime, like the beginning and end of a mountain range. Yet the entropy increase remains physically real and causally significant in this picture. Earlier cosmic structures constrain later cosmic structures through gravitational and thermodynamic relationships that span the time dimension. The Big Bang does not cause later cosmic evolution, but provides boundary conditions that determine the entropy gradient throughout spacetime. Causation becomes constraint, satisfaction across 4 dimensions, rather than temporal pushing from past to future. This understanding of cosmic entropy helps resolve apparent contradictions in the block universe picture. Critics often argue that if the future already exists, then the entropy increase violating the second law of thermodynamics should be equally probable as entropy increase satisfying it. But this argument assumes that the block universe must contain equal amounts of entropy increase and entropy decrease, which is not required by the theory. The block universe contains whatever entropy distribution actually exists in our cosmos, and that distribution happens to show systematic increase in one temporal direction. This increase does not violate thermodynamics, because thermodynamics describes correlations between events at nearby spacetime locations rather than global properties of the entire block. The second law remains valid locally, while the block universe determines the global entropy pattern. Biological evolution provides another illustration of how irreversible processes work in the block universe. Over cosmic time, life has evolved from simple chemical reactions to complex ecosystems capable of consciousness and technology. This evolutionary progression represents entropy decrease in biological systems, powered by entropy increase in their environments as solar energy drives the chemical processes of life. In the block universe picture, all stages of biological evolution exist simultaneously at their respective temporal coordinates. Early prokaryotic cells exist at ancient temporal locations. Modern complex organisms exist at recent temporal locations, and the evolutionary relationships connecting them represent geometric patterns spanning billions of years of space-time. Natural selection is not a process that shaped life through time, but a constraint that shaped the pattern of biological world lines across time. This perspective does not eliminate the reality of evolutionary change, but relocates it from temporal flow to space-time geometry. Organisms really do develop greater complexity and sophistication at later temporal coordinates compared to earlier ones. The evolutionary arrow of increasing complexity aligns with the thermodynamic arrow of increasing entropy, because biological complexity emerges from the dissipation of environmental energy. Human history and individual lifetimes follow similar patterns. Your personal development from infant to adult represents entropy changes in the complex chemical systems that constitute your body and brain. Learning and memory involve creating new neural connections that represent organized information about past experiences. Aging involves accumulated entropy increase in biological systems over time. In the block universe, your entire life spans decades of temporal coordinate space, with your infant self existing at early temporal locations and your elderly self existing at later temporal locations. The psychological development connecting these different temporal stages represents constraint patterns that shape your four-dimensional world line, rather than temporal evolution from one moment to the next. Yet your personal entropy changes are embedded within larger thermodynamic cycles that span cosmic scales. The energy that powers your metabolism comes from nuclear fusion in the sun, which converts hydrogen into helium while increasing solar entropy. Solar energy reaching Earth drives weather patterns, ocean currents, and photosynthesis that support the complex ecosystems within which human life exists. These nested thermodynamic cycles create hierarchical arrows of time at different scales. Your personal biological arrow aligns with Earth's ecological arrow, which aligns with the solar system's stellar evolution arrow, which aligns with the galaxy's gravitational collapse arrow, which aligns with the cosmic entropy increase arrow. All these arrows point in the same temporal direction because they are all consequences of the same low entropy boundary condition at the Big Bang. This hierarchy suggests that the arrow of time is not a fundamental feature of time itself, but consequence of specific initial conditions that characterize our particular universe. Time as dimension is reversible, but our cosmos happens to contain boundary conditions that create systematic entropy gradients throughout space-time. The arrow emerges from cosmology rather than chronology, from the specific structure of our space-time, rather than the general nature of temporal dimensions. Yet this leaves a deep mystery. Why did our universe begin with such low entropy? Was this initial condition selected by some physical principle we do not yet understand? Does it result from quantum mechanical boundary conditions in the early cosmos? Could it emerge from deeper physical laws that operate in higher dimensional spaces? These questions point toward connections between thermodynamics and quantum gravity that remain at the frontiers of theoretical physics. The arrow of time also raises questions about the relationship between physical irreversibility and conscious experience. Why does consciousness experience temporal asymmetry in the same direction as thermodynamic irreversibility? Is this correlation accidental, or does it reveal deep connections between mind and entropy? These questions lead towards some of the most challenging problems in neuroscience and philosophy of mind. You stand at a crossroads, weighing two job offers that will shape the rest of your life. One promises security but little excitement. The other offers adventure but uncertain prospects. You deliberate carefully, imagining different possible futures, consulting friends and family, wrestling with competing values and desires. After days of consideration, you finally choose the adventurous path, confident that this decision reflects your deepest values and authentic self. But if the block universe is real, then your choice was written into the fabric of space-time billions of years before you were born. Your future self, celebrating the successes and facing the challenges of the adventurous career, already exists at specific temporal coordinates in the four-dimensional structure of reality. The decision you agonized over was predetermined not by external forces, but by the unchanging geometry of space-time itself. This raises the most unsettling question about the block universe. If all events already exist in eternal space-time, do we truly choose anything at all? Are our decisions genuine expressions of free will, or elaborate illusions created by consciousness that cannot see its own predetermined future? The answer depends on what we mean by choice, freedom, and moral responsibility in a universe where becoming is illusion and being is all that exists. Traditional debates about free will usually assume that time flows and focus on whether the future is determined by the past. Hard determinists argue that if present events are completely determined by prior causes, then free will is impossible because we cannot do otherwise than what the causal chain compels. Libertarians respond that quantum indeterminacy or agent causation breaks the deterministic chain, preserving genuine choice and moral responsibility. Compatibilists claim that free will can coexist with determinism as long as our actions flow from our own desires and reasoning processes. The block universe disrupts this entire debate by eliminating the temporal flow these positions presuppose. In the block universe, there is no causal chain pushing events from past to future, because all events exist simultaneously at their space-time coordinates. There is no quantum indeterminacy creating open futures, because future events exist as definitely as past events. There is no temporal becoming for agent causation to influence, because agents and their actions coexist eternally in four-dimensional space-time. Yet the block universe might preserve a different kind of freedom, one based on ownership rather than alternatives. When you choose the adventurous career path, that choice belongs to you in a deep sense, even if it already exists in space-time. The decision emerges from your values, your personality, your reasoning processes, your emotional responses to different possibilities. It expresses who you are as a four-dimensional being extended through time, rather than who you become through temporal flow. Think of it this way. A river carves its path through a landscape based on the topography it encounters, the hardness of different rock formations, the slope of the terrain, the volume of water it carries. The river's path is determined by these factors, yet we still say the river carved the canyon because the shape of the canyon expresses the river's characteristic patterns of flow and erosion. Similarly, your world line through space-time might be determined by the structure of reality while still expressing your characteristic patterns of thought and decision. This perspective suggests that what matters for free will is not whether you could have done otherwise, but whether your actions authentically express your agency. In the block universe, your future self exists because you are the kind of person who would choose the adventurous path when faced with that particular decision. The choice is genuinely yours, even if it is written into the space-time structure, because it flows from the deepest features of your identity and character. But this raises puzzling questions about moral responsibility. If someone commits a terrible crime, are they blameworthy for an action that already existed in the block universe before they were born? If someone performs a heroic rescue, do they deserve praise for actualizing something that was always present in space-time? How can we hold people accountable for predetermined actions or credit them with predetermined virtues? Perhaps moral responsibility survives because it serves important functions regardless of the temporal structure in which it operates. When we blame someone for wrongdoing, We are not just responding to their past actions, but shaping their future behavior and the behavior of others who observe our response. Moral emotions like guilt, pride, gratitude, and resentment create social pressures that influence how people act in subsequent situations. In the block universe, these moral practices still work effectively, even if they do not work through temporal causation. Your disapproval of someone's dishonest behavior exists at temporal coordinates subsequent to their dishonesty, and this disapproval participates in the space-time pattern that determines how they behave in later situations. Moral responsibility becomes a feature of the four-dimensional social fabric rather than temporal social dynamics. Consider punishment and reward in this context. When society punishes criminals, the stated goal is often to deter future crimes and rehabilitate offenders. But if the future already exists, can punishment actually prevent crimes or change criminals? The answer depends on understanding punishment as part of the space-time pattern that makes certain futures actual rather than as temporal intervention that changes predetermined futures. Criminal behavior, societal response, and subsequent behavioral changes all exist together as integrated pattern in the block universe. The punishment does not temporally cause the rehabilitation. Rather, the punishment and rehabilitation coexist as parts of a four-dimensional social structure where earlier events constrain later events through relationships that span the time dimension. Effective criminal justice becomes a matter of creating space-time patterns that minimize harmful behavior rather than temporal processes that deter future crimes. This view might actually strengthen certain aspects of moral thinking by emphasizing the lasting reality of moral significance. In the flowing time picture, past wrongdoing fades into non-existence, while future consequences remain uncertain. But in the block universe, moral actions have permanent reality at their space-time coordinates. Historical injustices are not diminished by temporal distance, because they exist as fully real features of the eternal space-time structure. Similarly, moral progress becomes written into the fabric of reality rather than temporary historical achievement that could be lost through backsliding. When societies eliminate slavery, grant universal suffrage, or establish human rights protections, these moral advances become permanent features of space-time rather than fragile accomplishments that exist only in the flowing present. Personal moral development follows similar patterns. When you overcome destructive habits, develop compassion, or learn to act with integrity, these changes represent permanent features of your world line through space-time. Your growth is not something you achieve and then must maintain through ongoing effort. It is something you are across the temporal dimension of your existence. Yet this perspective raises troubling questions about moral effort and striving. If your future moral character already exists in space-time, why struggle to become a better person? If your attempts at self-improvement are predetermined, do they have any real significance? The answer lies in understanding that your moral efforts are among the factors that make your future moral character what it is in the block universe. Your current struggle with temptation, your deliberate practice of virtue, your reflection on ethical principles, all participate in the space-time pattern that determines what kind of person you are at later temporal coordinates. The effort is not temporally prior to the result, but geometrically related to it, like the base of a mountain is geometrically related to its peak. Your moral striving does not produce your moral character through temporal causation, but expresses your moral character through four-dimensional structure. This view preserves the meaning of moral effort, while eliminating the anxiety that comes from thinking your future character depends entirely on your current choices. Your character is not something you must create through temporal becoming, but something you are through temporal being. The responsibility is real, but not burdensome, because it reflects who you are rather than what you must accomplish. But critics argue that this dissolves genuine moral agency into metaphysical determinism dressed in comforting language. They claim that if your actions are features of eternal space-time structure, rather than products of temporal decision-making, then you are not truly responsible for them, regardless of how authentically they express your character. Moral responsibility requires the ability to do otherwise, and the block universe eliminates this ability by making alternative actions mere fantasies rather than real possibilities. Defenders of block universe ethics respond that alternative possibilities are irrelevant to genuine moral responsibility. What matters is not whether you could have acted differently, but whether your actions flow from your own moral agency rather than external compulsion. A decision made under hypnosis or at gunpoint lacks moral significance, not because alternatives were unavailable, but because the action did not authentically express the agent's values and reasoning processes. This source-based conception of responsibility fits naturally with the block universe because it focuses on the relationship between agents and actions rather than the temporal process by which actions come into existence. Your charitable donation is morally praiseworthy because it expresses your compassion and generosity, not because you could have been selfish instead. Your honesty is virtuous because it reflects your commitment to truth, not because deception was available as an alternative. The block universe might even enhance moral responsibility by eliminating excuses based on temporal distance or changed circumstances. You cannot claim that past wrongdoing is irrelevant because you have changed since then, because all temporal stages of your world line are equally real and equally you. You cannot postpone moral obligations by claiming they apply only to your future self, because your future self is as real and present as your current self. Yet questions remain about moral motivation in a predetermined universe. If your future actions already exist in space-time, why exert effort to make good choices? If moral outcomes are fixed, why engage in ethical deliberation at all? These questions confuse prediction with predetermination, mistaking knowledge about space-time structure for the structure itself. The fact that your future actions exist in space-time does not mean they exist independently of your current decision-making processes. Rather, your deliberation, your moral reasoning, your struggle with competing values, all participate in the four-dimensional pattern that determines what your future actions will be. The deliberation is not separate from the outcome, but part of the space-time structure that makes that particular outcome actual. Think of moral deliberation as exploration rather than creation. When you wrestle with an ethical dilemma, you are not creating your future choice, but discovering what choice expresses your deepest values and commitments. The deliberation reveals who you are across the time dimension, rather than determining who you will become through temporal development. The process remains meaningful because it constitutes the relationship between your character and your actions rather than the temporal evolution from character to action. This exploratory view of moral agency preserves the phenomenology of ethical choice while accommodating block universe metaphysics. You experience genuine uncertainty about what you will choose because you do not have access to information about future temporal coordinates. You must engage in authentic moral reasoning to discover what choice aligns with your values, because this reasoning process is among the factors that determine the alignment. The result is a picture of ethics where moral responsibility is real but not anxious, where character matters but is not fragile, where choices are meaningful but not burdensome. You are responsible for your actions because they express who you are, not because you created them through temporal agency. Your character is solid and reliable because it is written into space-time, not because you maintain it through ongoing effort. Your choices matter because they constitute your identity, not because they determine your future. Not every philosopher or physicist accepts the block universe as the final word on time's nature. Despite relativity's apparent support for eternal space-time, alternative theories attempt to preserve temporal flow, genuine becoming, and objective distinctions between past, present, and future. These theories face formidable challenges from modern physics, but they offer compelling responses to the existential anxieties that the block universe creates about free will, moral responsibility, and the meaning of human experience. The most intuitive alternative is presentism, the theory that only the present moment exists. According to presentists, the past has ceased to exist and the future has not yet come into being. Reality consists entirely of whatever is happening now, with all past events having vanished into nothingness and all future events remaining purely potential rather than actual. This view preserves our common sense intuitions about temporal flow by making the present moment objectively special and temporally privileged. Presentism faces immediate problems with relativity theory. If simultaneity is relative, as Einstein demonstrated, then there is no universal present moment that defines what exists now throughout the universe. Events that are present for you might be past or future for observers, moving at different velocities. This means presentism must either deny relativity, which contradicts overwhelming experimental evidence, or admit that existence itself is relative to reference frames, which seems to make reality observer dependent in disturbing ways. Some presentist philosophers attempt to reconcile their view with relativity by proposing that one particular reference frame represents absolute simultaneity, even if we cannot identify which frame that is. Perhaps there exists a cosmic reference frame, possibly defined by the expansion of the universe, or the cosmic microwave background radiation, that determines universal simultaneity and objective presentness. But this approach requires adding absolute simultaneity back to relativity theory, contradicting the principle that made relativity so successful in explaining electromagnetic phenomena. Other presentists embrace the relativity of existence, arguing that what exists now depends on your state of motion, just as what exists here depends on your spatial location. This relative presentism preserves temporal flow while accommodating relativity, but it leads to bizarre consequences. If you and I are moving relative to each other, then events that exist for you might not exist for me. We would inhabit different realities with different collections of existing events, connected only by the accidents of our relative motion. The growing block theory offers a compromise between presentism and the full block universe. According to this view, the past and present exist, but the future does not yet exist. Reality resembles a growing crystal, with new moments crystallizing into existence as time advances. The present represents the growing edge of reality, when new events come into being, while the past consists of moments that have solidified into permanent existence. Growing block theorists argue that their view preserves genuine temporal flow by making the passage of time literally the growth of reality. Time flows because new moments are constantly being added to the existing structure, expanding the domain of what has become real. This growth is not movement through a pre-existing time dimension, but the literal creation of new temporal reality as the universe evolves from past through present toward future. But the growing block faces similar problems with relativity as presentism. If simultaneity is relative, then the boundary between existing past and non-existent future cannot be objectively defined. Different observers would identify different growing edges, leading to the conclusion that the growth of reality itself depends on reference frames. Some events would exist for certain observers, but not for others, fragmenting reality into observer-dependent pieces. Growing block theorists respond with various strategies to identify an objective present boundary. Some appeal to quantum mechanics, arguing that the collapse of quantum superpositions defines moments when events become real. Others invoke thermodynamics, suggesting that the increase of entropy marks the boundary where possibilities become actualities. Still, Others propose that gravity or other fundamental forces determine the objective passage of time. These approaches attempt to ground temporal flow in physics rather than pure philosophy, but they face technical difficulties. Quantum mechanics might not actually involve collapse, but rather branching into multiple realities. Thermodynamics describes statistical tendencies rather than fundamental temporal processes. Gravity operates according to relativity theory, which eliminates absolute simultaneity. None of these physical phenomena seems to provide the objective temporal flow that growing block theory requires. Dynamic theories of time face deeper conceptual problems beyond their conflict with relativity. If temporal flow is real, then time itself must change. But change presupposes time. To say that time flows at 1 second per second is either circular reasoning or implies that temporal flow must be measured against some more fundamental temporal standard. This leads to infinite regress unless we eventually reach a level of temporal description that does not itself flow. Some philosophers embrace this regress by proposing hierarchical time structures. Perhaps our ordinary time flows through a higher dimensional hypertime, which itself flows through a still higher dimensional time, and so on infinitely. But this multiplication of temporal dimensions seems to create more problems than it solves. If every level of time requires a higher level to flow through, then no level can provide the fundamental temporal flow that motivated the theory in the beginning. Dynamic theorists also struggle to explain what causes temporal flow. If time flows, then something must drive this flow. Some mechanism must push reality from past through present toward future. But what could this mechanism be? It cannot be a physical force, because physical forces operate within space-time rather than acting on space-time itself. It cannot be logical necessity, because logical relationships are timeless rather than temporal. The flow of time seems to require a mysterious non-physical cause that operates outside the domain of scientific investigation. The causal set approach offers a more radical alternative by fundamentally reconceiving the nature of space-time itself. Instead of treating space-time as a continuous four-dimensional manifold, causal set theorists propose that space-time consists of discrete events related by causal connections. Time emerges from the causal ordering of these events rather than providing a background stage on which events occur. In causal set theory, temporal flow might emerge from the discrete addition of new events to the causal network. Reality grows not by moving through pre-existing time, but by adding new causal connections to the expanding web of relationships between events. This growth happens at the fundamental level of space-time structure rather than being imposed as an additional assumption about temporal flow. But causal set approaches face their own technical challenges. They must explain how the discrete causal structure gives rise to the continuous space-time that relativity describes. They must show how quantum mechanical phenomena emerge from purely causal relationships. They must demonstrate that their discrete growth processes produce the observed symmetries and conservation laws of physics. These requirements have proven difficult to satisfy in detailed mathematical models. Loop quantum gravity provides another approach to time that might preserve temporal flow at the fundamental level. According to this theory, space and time themselves are quantized at the Planck scale, consisting of discrete units rather than continuous dimensions. At these microscopic scales, the smooth spacetime of general relativity breaks down into a quantum foam of fluctuating geometric relationships. Some loop quantum gravity theorists suggest that temporal flow emerges from quantum processes at the Planck scale. Perhaps the growth of spatial volume or the evolution of quantum geometric states provides the fundamental mechanism that drives temporal becoming. If spacetime itself is quantum mechanical rather than classical, then quantum uncertainty might preserve genuine temporal flow against the deterministic implications of classical relativity. However, most approaches to quantum gravity, including loop quantum gravity, still treat time as a dimension rather than a flowing medium. The quantum processes occur in space-time rather than driving space-time forward through some external temporal dimension. While these theories might modify our understanding of space-time at microscopic scales, they do not necessarily restore the flowing time of common-sense experience. Shape dynamics represents an even more radical departure from conventional space-time physics. This approach eliminates time as a fundamental dimension and instead treats temporal evolution as changes in the shape of spatial geometry. Instead of objects moving through space-time, spatial shapes evolve according to dynamical laws that govern how geometry changes from one configuration to another. In shape dynamics, temporal flow becomes real because it represents genuine changes in spatial configuration rather than relationships between events at different temporal coordinates. The theory attempts to recover all the empirical predictions of general relativity while restoring temporal becoming as a fundamental feature of reality rather than an illusion created by consciousness. But shape dynamics faces the challenge of explaining why it produces the same empirical predictions as general relativity if it describes a fundamentally different reality. If space-time physics is just a mathematical convenience for describing shape changes, why does it work so well across such a wide range of phenomena? The theory must show that its radical reconceptualization of time provides genuine explanatory advantages rather than simply mathematical reformulation of existing physics. Emergent time theories take a different approach by arguing that time emerges from more fundamental timeless processes. Perhaps the deepest level of reality is timeless, consisting of mathematical structures or information processing patterns that exist outside temporal relationships. Time emerges at higher levels of organization, like temperature emerges from molecular motion, or wetness emerges from molecular interactions. These approaches might preserve temporal flow by making it an emergent rather than fundamental phenomenon. Just as biological evolution emerges from chemistry without being reducible to chemical laws, temporal flow might emerge from timeless mathematical structures without being reducible to those structures. The flow would be real at the level of human experience, while being absent from the fundamental level of physical reality. But emergent time theories must explain how temporal flow can emerge from purely timeless foundations. If the fundamental level contains no temporal relationships, how can higher levels exhibit genuine temporal evolution? The emergence of time seems to require more than the emergence of apparent temporal relationships. It requires the emergence of actual temporal flow from non-temporal foundations. Quantum mechanical approaches to temporal flow focus on the role of observation and measurement in quantum theory. Some interpretations of quantum mechanics suggest that the collapse of quantum superpositions creates genuine moments of becoming when multiple possibilities resolve into single actualities. If quantum collapse is fundamental to physics, then it might provide the objective temporal flow that other theories struggle to establish. The many worlds interpretation eliminates quantum collapse, but introduces a different kind of temporal flow through the branching of quantum realities. As quantum systems evolve, reality splits into multiple branches corresponding to different possible outcomes. Temporal flow becomes the process by which single quantum realities divide into multiple parallel realities, each containing different versions of subsequent events. But quantum approaches to temporal flow face interpretive difficulties. If quantum collapse is real, it must happen at specific moments. But quantum mechanics provides no mechanism for determining when collapse occurs. If many worlds branching is real, it produces an exponentially multiplying collection of parallel realities that seems to make human experience infinitesimally insignificant within the larger quantum multiverse. Despite these challenges, alternatives to the block universe continue to attract serious philosophical and scientific attention. They address real concerns about the implications of eternal space-time for human agency, moral responsibility, and existential meaning. They attempt to preserve aspects of temporal experience that seem too fundamental to dismiss as mere illusions. Yet none of these alternatives has succeeded in providing a compelling account of temporal flow that accommodates the empirical successes of relativity theory. They either conflict with well-established physics or require additional assumptions that seem unnecessary for explaining observed phenomena. The block universe remains the most empirically adequate description of space-time, even if it challenges our intuitive understanding of temporal experience. Quantum mechanics transforms our understanding of reality at the most fundamental level, revealing a universe that seems to exist in multiple states simultaneously until the moment of observation collapses these possibilities into definite outcomes. This quantum picture of reality as superposed possibilities, rather than definite facts, raises profound questions about the nature of time and existence that challenge both common sense and the block universe interpretation of relativity theory. Consider the famous double-slit experiment, where electrons fired one at a time through two parallel slits create an interference pattern on a detector screen. Each individual electron somehow passes through both slits simultaneously, interfering with itself to create the wave-like pattern that emerges over many trials. But when we place detectors at the slits to determine which path each electron takes, the interference pattern disappears and the electrons behave like particles taking definite paths through one slit or the other. This suggests that quantum systems exist in superpositions of multiple states until measurement forces them to collapse into single definite states. The electron is not simply traveling through one slit or the other prior to detection. It exists in a quantum superposition of traveling through both slits simultaneously. Only when we observe the system does it collapse into a definite state where the electron has taken a specific path. If quantum superposition and collapse are fundamental features of reality, then they seem to introduce genuine temporal becoming into physics. The moment of measurement represents a real transition from multiple possibilities to single actuality, from potential existence to definite existence. This quantum becoming might provide the temporal flow that relativity theory appears to eliminate, restoring genuine passage of time through the collapse of quantum possibilities. But quantum mechanics complicates the block universe picture in subtle ways. The theory itself is formulated in terms of evolution equations that describe how quantum states change over time. But these equations treat time as a parameter rather than a flowing dimension. The Schrödinger equation tells us how quantum amplitudes evolve from one temporal coordinate to another, but it does not describe time itself flowing or passing. Moreover, the evolution described by quantum mechanics is completely deterministic and time reversible when no measurements occur. A quantum system left to itself evolves according to precise mathematical laws that work equally well forward or backward in time. The apparent temporal flow comes not from the quantum evolution itself, but from the collapse events that interrupt this evolution when measurements occur. This raises deep questions about the nature of measurement and collapse in quantum theory. What exactly constitutes a measurement? When does collapse occur? Is collapse a real physical process, or simply a change in our knowledge about quantum systems? These questions remain controversial among physicists and philosophers, with different interpretations of quantum mechanics providing radically different answers. The Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s, treats measurement and collapse as fundamental features of quantum mechanics. According to this view, quantum systems exist in superpositions of multiple states until measurement interactions with macroscopic apparatus force them to collapse into definite outcomes. The collapse is real and irreversible, creating genuine moments of becoming when possibilities resolve into actualities. If the Copenhagen interpretation is correct, then quantum collapse might provide the temporal flow missing from relativity theory. Each measurement event represents a real transition from quantum uncertainty to classical definiteness, from multiple possibilities to single actuality. These collapse events could define objective moments of becoming that restore temporal flow to physics, even within the relativistic space-time framework. But the Copenhagen interpretation faces serious problems when combined with relativity theory. If collapse events define objective moments of becoming, then they must occur simultaneously throughout space to preserve the objectivity of temporal flow. But relativity eliminates absolute simultaneity, making it impossible to define when collapse occurs across spatially separated regions. Different observers would identify different collapse times for the same quantum systems, leading to observer-dependent versions of quantum reality. The many worlds interpretation, developed by Hugh Everett III in the 1950s, eliminates quantum collapse entirely by proposing that all possible outcomes of quantum measurements actually occur in parallel branches of reality. When you measure a quantum system, reality splits into multiple branches corresponding to different measurement outcomes. You experience only one branch, but all branches are equally real and continue evolving according to deterministic quantum laws. In the many worlds picture, there is no collapse and no moment of becoming when possibilities resolve into actualities. Instead, all possibilities remain actual in different branches of the quantum multiverse. Your experience of definite measurement outcomes results from the branching process that separates different versions of yourself into different quantum realities, each experiencing different outcomes. This interpretation preserves the deterministic evolution of quantum mechanics while explaining the apparent randomness of measurement outcomes. The randomness arises not because possibilities collapse into definite outcomes, but because conscious observers split into multiple versions that experience different outcomes in different branches. From any single branch perspective, the other outcomes seem merely possible, but they are actually real in other branches of the quantum multiverse. The many worlds interpretation fits naturally with the block universe because it eliminates the temporal becoming associated with quantum collapse. All branches of quantum reality exist simultaneously in the space-time structure, with branching representing geometric relationships in a higher dimensional space rather than temporal processes. The quantum multiverse becomes a vast branching structure where all possible histories exist as equally real geometric features. But many worlds raises disturbing questions about the significance of individual experience. If every possible version of your life exists in different quantum branches, then your actual choices and experiences become infinitesimally insignificant within the larger multiverse. Every possible mistake you might make is actually made in some branch. Every possible success is actually achieved in some branch. Every possible tragedy and triumph occurs somewhere in the vast quantum reality. This infinite multiplication of existence seems to drain meaning from individual choices and experiences. If all possibilities are equally real, then nothing you do makes any fundamental difference to the overall structure of reality. Your suffering is balanced by the happiness of other versions of yourself in other branches. Your achievements are matched by the failures of other versions in other branches. The significance of any particular life becomes lost in the overwhelming vastness of the quantum multiverse. Objective collapse theories attempt to preserve the reality of quantum collapse while providing precise physical mechanisms that determine when and where collapse occurs. These theories modify the Schrödinger equation to include nonlinear terms that cause quantum superpositions to spontaneously collapse into definite states after sufficient time, or when sufficient numbers of particles become involved in the superposition. The most developed objective collapse theory is the Ghirardi-Rimini-Weber model, which proposes that individual particles undergo spontaneous localization events at random intervals, averaging about once every 100 million years. For microscopic quantum systems, these localization events are extremely rare and do not significantly affect quantum behavior. But for macroscopic objects containing enormous numbers of particles, localization events occur almost continuously, ensuring that large objects always have definite positions and properties. If objective collapse theories are correct, then they might provide the temporal flow missing from purely relativistic physics. Each collapse event represents a genuine moment of becoming when quantum possibilities resolve into classical actualities. These events occur throughout space-time according to the objective physical laws governing collapse, creating real temporal flow through the spontaneous resolution of quantum uncertainties. But objective collapse theories face challenges in reconciling their nonlinear evolution equations with the requirements of relativity theory. The collapse mechanisms must be formulated to preserve relativistic covariance while still providing objective temporal flow. This requires careful mathematical construction that has proven difficult to achieve in fully satisfactory form. Quantum gravity theories attempt to unify quantum mechanics with general relativity by treating space-time itself as a quantum mechanical system. In these approaches, the geometry of space-time exists in quantum superpositions until measurement or other physical processes cause it to collapse into definite geometric configurations. Time might emerge from quantum gravitational processes rather than providing a background framework within which quantum evolution occurs. Loop quantum gravity quantizes space-time by treating it as a network of discrete quantum geometric relationships. In this picture, continuous space-time emerges from underlying quantum discrete structures, much like continuous fluid behavior emerges from underlying discrete molecular interactions. Time might emerge from the quantum evolution of these discrete geometric networks, rather than being fundamental to the description of quantum processes. String theory approaches quantum gravity by treating fundamental particles as vibrating strings rather than point objects. These strings exist in higher dimensional space-time manifolds that include extra spatial dimensions beyond the three we observe. Time might be emergent from string dynamics in these higher dimensional spaces rather than being one of the fundamental dimensions of reality. But most quantum gravity theories still treat time as a dimension or parameter in their mathematical formulations rather than as a flowing medium. Even when space-time itself is quantized, the quantum evolution typically occurs with respect to some temporal parameter that does not itself flow. These theories modify our understanding of space-time at microscopic scales without necessarily restoring the flowing time of everyday experience. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, eliminates time altogether by treating the universe as a timeless quantum system. In this approach, time emerges from quantum correlations between different parts of the universal quantum state, rather than providing an external framework within which quantum evolution occurs. The equation describes the quantum amplitude for different spatial geometries without reference to temporal evolution or temporal flow. This timeless quantum cosmology fits naturally with the block universe interpretation because it eliminates temporal becoming even at the fundamental quantum level. The universe exists as a timeless quantum superposition of all possible space-time geometries, with apparent temporal evolution emerging from correlations within this timeless quantum state. Individual observers experience temporal flow through their quantum mechanical interactions with other parts of the universe, but this flow is phenomenological rather than fundamental. Relational quantum mechanics, developed by Carlo Rovelli, proposes that quantum properties exist only relative to observing systems rather than absolutely. A quantum system does not have definite properties independent of measurement, but only acquires definite properties in relation to specific measuring apparatus. Different observers might experience different quantum realities depending on their interaction histories with the quantum systems they observe. This relational approach to quantum mechanics parallels the relational approach to simultaneity in relativity theory. Just as events are simultaneous only relative to specific reference frames, quantum systems have definite properties only relative to specific observing systems. The combination of relational quantum mechanics with relativistic spacetime might produce a fully relational physics where all properties, both quantum and spatio-temporal, exist only in relation to specific observing perspectives. But relational approaches raise questions about the objective reality of physical properties and processes. If quantum properties exist only relative to observers, and spatio-temporal relationships exist only relative to reference frames, then what remains of objective physical reality independent of observing systems? The relational approach might solve problems of quantum measurement and relativistic simultaneity by eliminating objective reality altogether. Quantum entanglement adds another layer of complexity to questions about time and locality. When quantum systems become entangled, measurements performed on one system instantaneously affect the quantum state of distant entangled systems, apparently violating the relativistic prohibition against faster-than-light influence. These quantum correlations seem to connect distant events in ways that transcend ordinary spatio-temporal relationships. Some physicists interpret quantum entanglement as evidence that space-time emerges from more fundamental quantum informational relationships, rather than providing the stage on which quantum processes occur. In this view, the apparent non-locality of quantum correlations reveals that spatial and temporal separations are emergent features of reality, rather than fundamental aspects of the universe's structure. If space-time emerges from quantum information processing, then time itself might be emergent rather than fundamental. The flow of time might represent the evolution of quantum information, rather than evolution within a temporal dimension. This informational approach to time connects quantum mechanics with computational and information-theoretic approaches to fundamental physics. But quantum informational approaches to space-time and time remain highly speculative and face significant technical challenges. They must explain how the continuous space-time of relativity emerges from discrete quantum information processing. They must show how relativistic symmetries and gravitational phenomena arise from purely informational foundations. They must demonstrate that their quantum informational structures can reproduce all the empirical successes of conventional space-time physics. The intersection of quantum mechanics with temporal philosophy remains an active area of research with no clear consensus among physicists and philosophers. Different interpretations of quantum mechanics lead to radically different conclusions about the nature of time, temporal flow, and the reality of temporal becoming. The block universe interpretation remains consistent with many quantum theories, but quantum mechanics introduces new possibilities for understanding temporal experience that were not available in purely classical physics. Sarah sits by her grandmother's hospital bed, holding a weathered hand that once taught her to bake cookies and tie shoelaces. The machines beep steadily, marking time in a room where time seems suspended between memory and anticipation, between holding on and letting go. Tomorrow, the doctors will remove life support, but tonight, grandmother is still here, breathing, present, real in ways that feel more vivid than any physics equation could capture. If the block universe is true, then this moment exists eternally at its space-time coordinates, as permanent and unchanging as the location of Mount Everest. Grandmother's birth 92 years ago exists at different temporal coordinates, equally real and equally present in the four-dimensional structure of reality. Her death tomorrow exists at yet other coordinates, as definite and unchangeable as her birth, as permanent as this bedside vigil. Yet knowing this brings Sarah little comfort. The eternal existence of all moments does not ease the pain of separation or diminish the significance of loss. Instead, it raises profound questions about how human meaning survives in a universe where becoming is illusion and all events exist simultaneously in static space-time. If nothing truly changes, if all moments are equally real, if temporal flow is merely psychological projection, then what gives life meaning, purpose, direction, hope? These questions strike at the heart of human existence because meaning seems intimately connected to temporal experience. We find purpose in working toward future goals, significance in learning from past mistakes, satisfaction in witnessing growth and development over time. Love deepens through shared experiences across years of relationship. Wisdom emerges from accumulated life experience spanning decades of learning. Achievement requires sustained effort directed toward future outcomes that do not yet exist. The block universe seems to undermine all these sources of meaning by eliminating genuine temporal development. If your future self already exists at definite space-time coordinates, then your efforts to improve yourself appear pointless. If your relationships with others are eternal geometric features of space-time, then the growth of love through time becomes mere illusion. If your achievements are permanent fixtures in the block universe, then the struggle to accomplish them loses its significance. But perhaps this view misunderstands how meaning works in both flowing time and eternal space-time. Consider a great novel like War and Peace, where all the events exist simultaneously on printed pages with beginning, middle, and end equally present in the physical book. Yet readers experience profound meaning in the story's unfolding. Character development, plot twists, emotional climaxes, thematic resolution. The simultaneous existence of all parts does not diminish the meaning that emerges from their sequential experience. Similarly, the simultaneous existence of all life moments in the block universe does not eliminate the meaning that emerges from their sequential experience through consciousness. Your personal growth from childhood to adulthood is meaningful because it represents genuine development along your world line through space-time, even though all stages exist simultaneously at their respective temporal coordinates. The meaning lies in the pattern of connections linking different temporal stages rather than in temporal becoming itself. Love takes on new dimensions in this eternal context. When you love someone, you love their entire four-dimensional existence across time rather than just their current temporal slice. Your beloved exists complete in space-time with their childhood innocence, youthful passion, mature wisdom, and eventual aging all simultaneously real and equally lovable. Death cannot truly separate you because they exist eternally in the block universe, accessible through memory and forever present at their space-time coordinates. This perspective transforms grief into a different kind of experience. Sarah mourns not the annihilation of her grandmother, but her inability to share new experiences with her. Grandmother exists as fully as ever in earlier sections of the block universe, laughing at family dinners, telling bedtime stories, teaching life lessons. These moments are not memories of something that no longer exists, but connections to eternal realities at other temporal locations. Yet grief remains real and meaningful because it reflects the genuine limitations of consciousness embedded in space-time. Sarah cannot access her grandmother's presence at earlier temporal coordinates any more than she can visit distant galaxies at remote spatial coordinates. The separation is real, even if both parties exist eternally at their respective space-time locations. Grief expresses the poignant fact that conscious experience is local in time as well as space, creating genuine limitations and genuine losses. Personal identity becomes more complex and perhaps more comforting in the block universe. Instead of being a single thing persisting through time, you are an extended four-dimensional entity with different temporal parts at different temporal coordinates. Your childhood self is not gone, but exists permanently at earlier temporal locations. Your future self is not approaching, but already exists at later temporal locations. You are not a brief flicker of consciousness in an indifferent universe, but an eternal structure woven into the fabric of space-time itself. This four-dimensional conception of identity might actually strengthen rather than weaken personal meaning. Your life is not a temporary arrangement of matter that will someday disperse into chaos, but a permanent feature of reality as enduring as any mountain range or stellar constellation. Your experiences, relationships, achievements, and even struggles become eternal aspects of the universe's structure, rather than temporary fluctuations in a cosmic void. Achievement and effort retain meaning in this context because they constitute the shape of your world line through space-time, rather than causing temporal changes from one moment to the next. When you work toward a goal, you are not creating something that does not yet exist, but discovering the path your four-dimensional existence takes through space-time. The effort is meaningful because it expresses your character and values across the temporal dimension of your being. Consider an artist spending years perfecting a masterpiece. In flowing time, the value seems to lie in the temporal process of creation, the gradual emergence of beauty from initial conception to final completion. But in the block universe, the value lies in the eternal relationship between artist and artwork, the four-dimensional pattern connecting creative intention with finished expression. The years of effort exist permanently at their temporal coordinates, as real and meaningful as the completed work itself. Education and personal growth work similarly in eternal space-time. When you learn something new, you do not change from ignorant to knowledgeable through temporal becoming, but rather exist as a four-dimensional being with ignorance at earlier temporal coordinates and knowledge at later coordinates. The learning process is meaningful because it represents the shape your world line takes through space-time, the pattern of development that constitutes your identity across time. Moral development follows the same logic. When you overcome character flaws or develop virtues, you are not temporally transforming yourself, but existing as a four-dimensional being with different moral qualities at different temporal locations. Your struggles with temptation, your efforts to act ethically, your gradual growth in wisdom and compassion, all exist permanently at their space-time coordinates as eternal features of who you are across time. But this eternal existence of moral stages raises questions about forgiveness and redemption. If your past wrongdoing exists permanently at earlier temporal coordinates, can you ever truly move beyond it? If your character flaws are eternal features of space-time, can moral improvement be anything more than illusion? The answer lies in understanding that moral development is real precisely because it spans the temporal dimension of your existence. Your past mistakes exist eternally, but so does your recognition of those mistakes, your regret about them, your efforts to do better, and your actual improved behavior at later temporal coordinates. The entirety of your moral journey, including both failings and growth, constitutes your four-dimensional moral identity. You are not defined by any single temporal slice, but by the complete pattern of your existence across time. Forgiveness becomes possible and meaningful because it represents an eternal relationship between different aspects of your four-dimensional existence. When you forgive yourself for past wrongs, you establish a permanent connection between earlier stages where you acted badly and later stages where you acknowledge and transcend that behavior. The forgiveness is not temporal healing, but spatial-temporal structural integration of your complete identity. Hope survives in the block universe, but takes on different meaning. Traditional hope looks forward to future improvements that do not yet exist. Block universe hope recognizes that your complete four-dimensional existence already includes whatever growth, healing, and positive development your life contains. The hope lies not in creating a better future, but in discovering the eternal pattern of your existence includes whatever meaning and fulfillment your life achieves. This might seem to eliminate motivation for effort and striving, but it actually relocates motivation from temporal creation to eternal expression. You strive not to create something that does not exist, but to express the deepest patterns of your four-dimensional identity. Your efforts matter because they constitute who you are across time, rather than because they produce temporal changes from one moment to the next. Relationships take on added significance when viewed across the full temporal dimension. Your friendship with someone is not just your current interactions, but the complete four-dimensional pattern of connection spanning decades of shared experience. Every conversation, every moment of support, every shared joy and sorrow exists permanently as part of the eternal structure linking your world lines through space-time. This eternal view of relationships might actually deepen their significance by emphasizing their permanent reality rather than their temporal fragility. Love is not something that grows and fades through time, but something that exists complete across time, connecting different temporal stages of different people in patterns of care, understanding, and mutual support that become permanent features of space-time geometry. Yet consciousness remains stubbornly local in its experience of this eternal reality. Sarah can know intellectually that her grandmother exists permanently at earlier temporal coordinates, but she cannot experience that existence directly. Consciousness seems confined to experiencing one temporal slice at a time, creating the illusion of flow through sequential access to different parts of the eternal block. This limitation of consciousness might be what preserves meaning rather than undermining it. If consciousness could access all temporal coordinates simultaneously, then the sequential development that gives life its narrative structure would be lost. Growth, learning, relationship development, and moral improvement all depend on consciousness experiencing temporal stages in sequence rather than all at once. Perhaps consciousness creates meaning by reading through the eternal story of existence one moment at a time, like reading through a great novel page by page, rather than grasping all pages simultaneously. The sequential experience generates the temporal development that makes life meaningful, even though all the temporal stages exist simultaneously in the block universe. This suggests that meaning emerges from the interface between eternal reality and local consciousness rather than from temporal flow itself. The block universe provides the objective structure within which meaning is possible, while consciousness provides the sequential experience that actualizes that meaning through temporal development. Neither alone is sufficient. Both together create the conditions within which human life can achieve significance and purpose. Art and creativity offer particularly powerful examples of how meaning emerges from this interface. A piece of music exists complete in space-time, with all its notes simultaneously present at different temporal coordinates, but consciousness experiences it sequentially, encountering each note in turn and appreciating the relationships between them as they unfold through psychological time. The music is meaningful because it creates patterns that consciousness can appreciate through sequential experience. Similarly, your life exists complete in the block universe, with all its experiences simultaneously present at different temporal coordinates. But consciousness experiences it sequentially, encountering each experience in turn and appreciating the relationships between them as they unfold through psychological time. Life is meaningful because it creates patterns that consciousness can appreciate through sequential experience of eternal structures. This dual nature of existence, eternal in space-time but sequential in experience, might explain why meaning feels both permanent and fragile, both cosmic and personal. Your achievements are permanent features of space-time that will exist forever, giving them cosmic significance, but they are also personal experiences encountered through local consciousness, giving them intimate meaning that cannot be reduced to their eternal existence. The block universe does not eliminate human meaning, but relocates it from temporal becoming to eternal being, structured through sequential conscious experience. Your life matters not because it creates something that did not exist before, but because it constitutes something that exists eternally in the fabric of space-time itself. You are not a temporary visitor in an indifferent universe, but a permanent resident in a reality that includes your complete existence as one of its essential features. We have traveled far from the simple intuition that time flows like a river, carrying us from past through present toward an uncertain future. The journey through modern physics has revealed a universe stranger than anything our ancestors could have imagined. A four-dimensional block where all moments exist simultaneously, where simultaneity depends on motion, where entropy increases not through temporal flow, but through geometric arrangements across space-time coordinates, yet questions remain. Despite the compelling arguments for the block universe, despite the elegant mathematics of relativity theory, despite the elimination of absolute simultaneity and universal time, we still do not know with complete certainty whether time is truly written into the eternal structure of space-time, or whether some deeper level of reality preserves the flowing temporal experience that feels so immediate and undeniable. Current physics provides the most empirically successful description of space-time ever developed, and that description strongly supports the block universe interpretation. Every experimental test of relativity theory confirms that simultaneity is relative, that time dilates with motion and gravity, that space-time forms a unified four-dimensional manifold where temporal and spatial coordinates mix and merge. These discoveries have been verified countless times through GPS satellites, particle accelerators, astronomical observations, and gravitational wave detectors. The mathematics of general relativity treats time as a dimension rather than a flowing medium, describing the geometry of space-time rather than the evolution of space through time. The field equations that govern gravitational phenomena make no reference to temporal flow, temporal becoming, or privileged present moments. They describe static relationships between matter, energy, and space-time curvature that exist timelessly throughout the four-dimensional block. Quantum mechanics, despite its apparent introduction of temporal becoming through measurement and collapse, can be formulated in ways that eliminate temporal flow entirely. Many worlds' interpretations preserve deterministic quantum evolution while eliminating collapse. Quantum field theories treat particle creation and annihilation as features of space-time geometry rather than temporal processes. Even quantum gravity theories typically describe timeless quantum states of space-time geometry rather than temporal evolution of quantum systems. Yet significant gaps remain in our understanding of fundamental physics that might affect conclusions about time's nature. We lack a complete theory of quantum gravity that successfully unifies general relativity with quantum mechanics. We do not understand the nature of dark matter and dark energy that appear to dominate cosmic evolution. We have no consensus interpretation of quantum mechanics and no definitive resolution of the measurement problem. These gaps leave room for speculation that deeper physical laws might restore temporal flow at fundamental levels. Perhaps quantum gravity theories will reveal that space-time itself is emergent from more basic temporal processes. Perhaps dark energy drives genuine cosmic evolution that transcends the static geometry of classical space-time. Perhaps the correct interpretation of quantum mechanics requires objective collapse that creates real moments of becoming throughout the universe. But the burden of proof lies with theories that claim to restore temporal flow, not with theories that eliminate it. The block universe interpretation emerges naturally from well-established physics without requiring additional assumptions about flowing time or privileged present moments. Alternative theories must not only accommodate the empirical successes of relativity and quantum mechanics, but also provide compelling reasons for adding temporal flow back into physical descriptions that work perfectly well without it. Moreover, the conceptual problems with temporal flow remain as challenging as ever. What could it mean for time itself to flow? Flow requires change, but change requires time, creating circular reasoning or infinite regress. How fast does time flow? 1 second per second is either tautological or requires additional temporal dimensions for time to flow through. What causes temporal flow? No known physical mechanism can push reality from past through present toward future. These conceptual difficulties suggest that temporal flow might be incoherent as a fundamental physical concept, regardless of what future physics discovers about space-time, quantum mechanics, or cosmology. The block universe might be the only consistent way to think about time at the deepest level of reality, even if human consciousness inevitably experiences this eternal structure through sequential temporal slices. Yet consciousness itself remains mysterious in ways that might affect our understanding of time. We do not understand how subjective experience arises from objective physical processes, how qualia emerge from neural activity, how the unity of conscious experience is constructed from distributed brain activity. If consciousness involves physical processes that transcend our current understanding, then it might interact with time in ways that current physics cannot capture. Some theories of consciousness propose that subjective experience requires quantum mechanical processes in neural microtubules, electromagnetic field interactions across brain regions, or information integration patterns that might be sensitive to relativistic effects. If consciousness depends on physical processes that current neuroscience does not fully understand, then the relationship between conscious temporal experience and physical temporal structure might be more complex than the block universe picture suggests. But these speculations remain highly controversial and lack strong empirical support. Most neuroscientists and philosophers of mind doubt that consciousness requires exotic physics beyond the well-understood electrochemical processes of neural activity. The hard problem of consciousness might be solved through conventional neuroscience and cognitive psychology, rather than through appeals to quantum mechanics or relativistic effects. Even if consciousness does involve exotic physics, it would not necessarily restore temporal flow to fundamental reality. Conscious experience might create the illusion of temporal flow through quantum mechanical or electromagnetic processes, while still being embedded within the static block universe described by relativity theory. The mystery of consciousness does not automatically solve the puzzle of temporal flow. Cosmological observations add another layer of uncertainty about time's ultimate nature. We observe a universe that appears to be expanding and evolving from simpler to more complex structures over cosmic time. Galaxies form from primordial density fluctuations. Stars ignite through gravitational collapse. Heavy elements synthesize through nuclear fusion. Planets develop complex chemistries, and at least one planet develops life and consciousness. This cosmic evolution seems to require genuine temporal development, rather than static geometric arrangements in space-time. How can galaxies form, stars evolve, and life emerge if all cosmic history exists simultaneously in the block universe? The appearance of cosmic development might be so compelling that it overrides theoretical arguments for static spacetime. But cosmic evolution is perfectly compatible with the block universe when properly understood. Galaxies do not form through temporal processes, but exist at their various developmental stages at different temporal coordinates throughout spacetime. Early cosmic times contain simple matter distributions. Later cosmic times contain complex galactic structures. And the progression from simple to complex represents geometric relationships across the time dimension rather than temporal evolution. The cosmic microwave background radiation provides dramatic evidence for this interpretation. This radiation fills space uniformly and represents thermal echoes from early cosmic times when the universe first became transparent to light. In flowing time, this would be ancient light that traveled through space for billions of years to reach us. In the block universe, it represents geometric relationships connecting early and late cosmic regions across space-time. Both interpretations make identical empirical predictions about what we observe, but the block universe interpretation is simpler because it requires no assumptions about temporal flow beyond what relativity theory already describes. The cosmic evolution we observe is real, but consists of geometric patterns across space-time rather than temporal processes unfolding through flowing time. Anthropic reasoning adds further complexity to questions about time and cosmic evolution. The fact that we exist to observe cosmic history places constraints on what kinds of universes could contain observers like ourselves. Perhaps our universe has the particular space-time structure it does because only universes with that structure can evolve conscious observers capable of asking questions about time's nature. If this anthropic reasoning is correct, then the appearance of cosmic evolution might reflect selection effects rather than fundamental temporal processes. We find ourselves in a universe with apparent temporal development not because time flows, but because only such universes can contain beings capable of experiencing apparent temporal development. The block universe might contain many different regions with different entropy gradients, but observers can only exist in regions where entropy increases create the conditions necessary for complexity and consciousness. This anthropic perspective suggests that questions about time's ultimate nature might be unanswerable from within the universe we inhabit. We are embedded within one particular space-time structure with one particular entropy gradient that creates the impression of cosmic evolution and temporal flow. But we cannot step outside this structure to observe whether it is fundamentally static or dynamic, whether it exists within flowing time, or constitutes the entirety of temporal reality. Perhaps the question of whether time is already written is like asking whether space is already positioned. Both questions assume a perspective outside space-time, from which temporal flow or spatial motion could be observed. But we exist within space-time and can only observe relationships between events at different space-time coordinates, not the flowing or positioning of space-time itself. This embedded perspective might explain why the debate between block universe and flowing time theories seems so difficult to resolve. Both theories make identical empirical predictions about what we observe from our position within space-time. The block universe describes geometric relationships between events at different coordinates. Flowing time describes dynamic evolution from one temporal state to another. But these descriptions might be different ways of representing the same underlying reality, rather than competing claims about fundamentally different realities. Yet the choice between these descriptions has profound implications for how we understand ourselves and our place in the cosmos. If time is already written, then our lives unfold according to eternal patterns that exist completely and permanently in the four-dimensional structure of space-time. Every choice we make, every relationship we form, every achievement we accomplish exists forever as part of the unchanging architecture of reality. This vision can be either comforting or terrifying, depending on one's perspective and temperament. It is comforting to know that nothing is ever truly lost, that all meaningful experiences exist eternally in space-time, that death cannot destroy the reality of lives lived and loves shared. It is terrifying to realize that all suffering also exists eternally, that mistakes cannot be undone, that the future is as fixed and unchangeable as the past. But these emotional responses might be based on misunderstanding the relationship between eternal existence and temporal experience. The fact that all moments exist eternally in space-time does not make temporal experience less real or meaningful. Reading a great novel is not less meaningful because all the words exist simultaneously on printed pages. Listening to beautiful music is not less moving because all the notes exist simultaneously in the composer's score. Similarly, living a meaningful life might not require temporal flow, but only sequential conscious experience of eternal temporal structures. Your growth from childhood to adulthood is real because it represents genuine development along your world line through space-time. Your relationships deepen over time because they create real patterns of connection spanning decades of temporal coordinates. Your achievements matter because they express your character across the temporal dimension of your existence. The block universe preserves everything that makes life meaningful while eliminating the anxiety that comes from thinking. Meaningful experiences are fragile and temporary. Your deepest experiences of love, beauty, understanding, and connection exist permanently in the structure of space-time rather than flickering briefly in the flowing stream of time before disappearing forever into non-existent pastness. Perhaps this is the deepest insight about time that modern physics provides. Not the elimination of meaning through static determinism, but the preservation of meaning through eternal existence. Every moment of consciousness, every flash of understanding, every gesture of compassion exists forever as part of the magnificent four-dimensional tapestry that constitutes reality itself. If time is a landscape rather than a river, then every step we take is already there in the eternal geography of space-time, but the view from each step remains uniquely ours. We discover rather than create the paths we follow through the temporal dimension, but the discovery is real and the paths are meaningful precisely because they connect us to the unchanging structure of everything that ever was, is, or will be. The question of whether time is already written might be the wrong question to ask. Instead of asking whether our lives are predetermined by eternal space-time structures, we might ask what kinds of eternal space-time structures our lives constitute. Instead of worrying about whether the future already exists, we might wonder what kind of future we are in the process of discovering already exists as part of who we are across time. This shift in perspective, from creation to discovery, from becoming to being, from temporal flow to eternal structure, might represent the deepest conceptual revolution that modern physics brings to human understanding. We are not temporary arrangements of matter struggling to create meaning in an indifferent universe. We are eternal features of space-time itself, as permanent and significant as any other aspect of reality's ultimate architecture. Time may indeed be already written, but we are among the authors whose lives constitute the writing. The story exists eternally, but it is our story, told in the universal language of four-dimensional geometry, across the vast space-time landscape of everything that was, is, and ever shall be. In learning to read this eternal story, we do not lose our humanity, but discover its cosmic significance. We find our place not as temporary visitors, but as permanent residents in the magnificent block universe that constitutes the deepest reality of space, time, and existence itself.